Somebody's aggressive.
Is this yes.
Oh my gosh! That was like 10 minutes ago, dude. I said it.
Refrigerators.
Refrigerators on wheels.
Oh, that's true.
I
A dog with
slapped
3
you.
legs. On wheels?
What
What kind of refrigerator do you have? Actually, that's not even wheels.
They're like, that's only 2 though. There's doors on a fridge. 2 doors on a fridge. There's 2 doors and wheels. It's still a 1-to-1 ratio.
So you can't.
Yeah, there's no fridge. Unless you put wheels in your fridge. Yo, this sliding off the door next to the house. Yeah,
Those have wheels on it.
Yeah, NP is greater than equal to 10, and then it's
I hate this so much.
A microwave though? That's a door.
It's like chances to
But I have a spinning wheel.
Oh, that makes sense.
Oh, that's true.
And it has gears inside of it to make it work. There's definitely hella wheels.
It's just a
That's
lot
just
of
electrical
There's
energy.
definitely a lot of
Physics.
It's just something that you can't measure.
Can you imagine how many holes are under the
That's
ground?
that's
It's
a
a
high
whole
voltage.
thing.
Where is that?
Why are you arguing?
This is how many holes.
It is.
Yes, we do. You're surrounded by the doorway.
This is like the only part I get. Almost crazy.
We like
See, that's what I was trying to tell you. There's doors on top wheels.
Wait, what?
You better
Also, stir this. This is bad. It's not just
Anyways,
quiet back down, please. Andy's gonna plan for us.
See?
Oh, that alpha looks so weird. I thought it was just
That's an OC.
there's a little sleep,
No, 35 doors. I think. It's not that big. How many Hot Wheels do you have?
And the doors on Hot Wheels don't work.
So therefore they're
Well, only
so therefore they're
So,
what about all the toy trains?
what about all the toy trucks? Let's talk it.
Or the little toy car that Henry has with the door?
So it's a ratio of 4.
ratio.
Wheels
Guys,
to
talk
door.
about
How many cars
ratios.
are we using?
We can't get mad. How many cars is I should be proud.
Okay.
I'm
this car.
so proud. No, Michelle.
No, Michelle?
Michelle. No,
She was here during math. I mean, during English. Maybe she had to do it.
Yeah. Sadly, she has started making a habit of being about every other time she attends class.
Yeah, but it's still No.
They're still going.
It's gonna last a long time, so I'm scared what we started.
Washing machine thing, like in a tire that fits it.
I didn't done it yet.
I live in, it's 428 square feet, that's fucking fun. You tell me to go over now. That's like 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
Thank you, ma'am. All right, null hypothesis, p equals 0.083. She got that by taking 1 divided by 12, because it tells you that you're looking at 12 different singers. And we're assuming they all have the same odds of winning or being voted for. And then the question is there an advantage to going last? So our alternative would be that p is greater than 1 out of 12. P hat, 59 out of 600, so 0.0983. Then we checked our conditions. It sounds really close. Like, I don't usually hear sirens in class.
That's not great.
I think it's
gone.
video.
Maybe someone was making a video.
Yeah.
Anyway.
Then Jillian did all the hard work for you guys. Got a p value over here of 0.0867, z-score of 1.36. And then I did say, before you guys got into your argument about wheels and doors, that you didn't have to write the novel, you could just write the basics, which is what Jillian did. Because our p is greater than or equal to alpha, we failed to reject the null, which means we have weak evidence, so we cannot conclude the alternative that going last has an advantage. Questions?
What is it?
All right, today we're going to do a two-sided significance test. Yesterday we looked at it when our alternative was, I think it was less than, and then you guys had less than and greater than in your homework. Today we're going to look at a two-sided. Maybe I can open my packet. All right, according to the CDC website, 50% of high school students have never smoked a cigarette. McKenna wonders whether this national result holds true in her large urban high school. For her AP Statistics class project, McKenna surveys an SRS of 150 students from her school. She gets responses from all 150 students, and 90 say that they have never smoked a cigarette. What should McKenna conclude? All right, so state, what is our null hypothesis? What's the claim we're looking at?
50% of high school students never smoke a cigarette.
So H null is that P is equal to 50% or 0.5. And that's because we're going off of what the CDC website says. Now, it then says that McKenna wonders whether this result holds true. Doesn't tell us that she thinks it's less than in her high school or more than in her high school. She just isn't sure if it's actually true for her high school. So that means our alternative is P does not equal 0.5. We need to define P, which Maddie did for us. True proportion high school students who've never smoked a cigarette. True proportion high school students. Excuse me. Never smoked a cigarette. Alpha level is what? 0.05. It doesn't specify otherwise, so we use 0.05. And then we also need to give our P hat, which she surveyed 150. And out of those 150, excuse me, 90 had said they'd never smoked a cigarette, which would be what? What is it? 0.6. Thank you. Any questions on the state part? Okay, then we're going to go to plan. What's our calculator function? 1 prop z test. And our 3 conditions are what? Random, normal, independent. Thank you. It was Cheyenne, right? I'm getting better at knowing voices. So random tells us she took an SRS of 150 students. So I'm just going to quote that. SRS. Normal. How do we check normal with proportions? Thank you. N times P greater than or equal to 10. N times 1 minus P greater than or equal to 10. And like I've said before, these really are... Why is it blurry all of a sudden? Is it blurry to anybody else? Just me. Alright, so N times P, N sample size 150 times P 0.6 is just going to give us those 90 who said they had never smoked a cigarette before. And that means 150 times 1 minus P, 0.4 would be the other people from the survey that said they had smoked a cigarette, and that would be how many of them? 90 said they hadn't. How many have? 60. Both of those are greater than 10. And then independent. Our sample size is less than 1/10 of the population. She did 150 in her sample. If we multiply both sides by 10, we get that the population has to be greater than or equal to 1,500. Now this one is kind of weird because it's these words right here, large urban high school. I misspelled school. Whatever. Large urban high school. What would you say our school is? Are we urban, first of all? I don't even know if you can say we're suburban, but we kind of are. We're not outside a big city, nor are we a big city, though. So rural. And are we a large school? No. Compared to anything around here in Southern Oregon, we're big. But if you're in like the like LA, their high schools can have like 6,000 kids.
6,000.
How many do we
Yes.
have?
We have about 1,600. So we're actually pretty small. Say that again?
Did we used to have like 2,000?
We did used to have closer to 2,000.
But it dropped out.
Well,
Probably.
no. The class
Graduated.
sizes change. The freshman class, I can't remember, a few years ago, it was like 500. But then people moved to South, they moved to online school, whatever. Anyways, my point was, large urban high school, you can assume that's a very large school. And so we can assume that it's greater than 1,500 because we, North Medford, are not large, nor are we urban, and we have more than 1,500 kids. So this one is kind of weird in that sometimes they'll just have a statement like that that tells you, yep, your population is really big. So you can just assume it's bigger than 1,500. Any questions on the plan before we do the do? Mountain Dew should pay me for the amount of times I say do the do. All right. But I mean do the D-O do, not the D-E-W do. So we're going to draw our normal distribution. We're assuming H null is true, so we're going to have 0.5 at the center. Then we have to figure out our standard deviation, which would be 0.5 times 0.5 divided by 150 square rooted 0.25. Why didn't it accept square root? What did I do? Ah, poopers.
Oh, it's a negative.
0.0. No. There we go. 0.041. So that would be 0.541, 0.582. I do, yes. 0.623. That'd be, I really suck at subtraction in my head. 0.459. So then that'd be 0.418. 0.377. Right? Sorry. There we go. All right, so our p hat that we're looking at is 0.6, which is almost pretty much halfway in between these ones, right? P hat equals 0.6. Now, our alternative is not equal to, which means that we have a two-sided significance test. Right now, my p hat gives me this side, and I'm going to use symmetry to find the other side. So my p hat is 0.1 away from the center of my normal distribution. So I'm going to go 0.1 away on this side as well, which would be 0.4, which is going to be somewhere in here-ish. So I went the same distance away. My p hat gave me this side. I was 0.1 away from my center. So then I have to go 0.1 away on the other side because my alternative doesn't tell me whether I'm really focusing on less than or greater than, so I have to test both of them. Any questions before we get into the other parts of the do's? All right, so then the general formula, test statistic, comes from your statistic minus your parameter divided by your standard deviation. And our test statistic is Z. Our statistic is P hat. Our parameter is P. And then our standard deviation is that square root of P times 1 minus P all over N. P hat is 0.6, P is 0.5, and standard deviation is 0.041. And then when we put it in the calculator, we'll also get our P value. Any questions so far before I put the calculator in front of everything? Right. Noah, your calculator is not like me. All right. How did we get there? Stat. Tests. Number 5. So first one is your null hypothesis, so it's 0.5. Then the actual sample you took, so she had 90 out of 150 say they'd never smoked a cigarette, and then our alternative is not equal to. You want me to calculate or draw? Okay, sorry. No, it's okay. We'll draw. Never mind. We won't draw. Seriously, your calculator is not like me, Noah.
I don't know what to say.
Because it's on.
So you can see when you draw that it shaded both sides, like I drew in my picture. Z-score is 2.45. If we round, p-value 0.0143. And then, of course, if we did calculate, we'd get the same things. 2.45 for the z-score, 0.0143 for the p-value. 2.45 for our z. And this 0.0143. All right, well, you guys lucked out. I didn't leave much room for myself to conclude, so we'll just do the basics again. So, are we going to reject or fail to reject the null? Why? It's less than our alpha. Have more faith in yourself. Our p-value is less than alpha, which means we have strong or weak evidence. Strong evidence against H null. And like Maddie said, that means we reject H null. And what's our conclusion? We conclude the alternative, which says that P does not equal 0.5. And apologize about that statement. Long time ago when I first started teaching, I made him do a day of doing this stuff by hand, and then I taught him the calculator. So that's why that sentence is there. But I already taught you the calculator, so it's redundant at that point. Any questions? No? All right, so down below, it tells us that our significance test above led us to reject H null and H null told us that P equals 0.5. But our significance test didn't actually help us figure out what the actual proportion might be. And so a confidence interval would give us a little more insight into whether the true proportion of high school students who have never smoked is less than 0.5 or greater than 0.5. Because our significance test just told us that we can conclude it's not equal to 0.5, but it doesn't tell us one way or the other. So, you guys get to practice your Chapter 8 skills. I don't know why I stuttered with that word, skills. I want you to construct and interpret. What does that tell you? State, plan, do, conclude. Thank you, Cheyenne. 95% confidence interval for the true proportion of high school students who have never smoked a cigarette. Now, some of the parts you can say see above because we already did it, like plan. There's no point in checking the conditions again. But you guys should state. Say that again? What did you say, Calvin?
Never a.
Oh, I shouldn't talk and write. Never smoked. Thank you. So for your confidence interval, you need to state the plan we already did above, so just say see above. Then do, conclude. I bet you guys missed those conclusions. It was one sentence. Good reminder for those of you that still need to finish your Unit 8 test. Those in reminders. Comments, okay.
I'm like the inside.
Should I? Maybe like the last day.
So we don't.
Can I just say,
Oh, yeah.
Then you have to say, I don't know, 95% confidence.
You're good popping?
I don't mean to have Were you recording me?
No, I was just on my
Oh.
phone. It wasn't even
He quickly, I looked over and he quickly covered it up.
I don't know why.
I don't mean a hip replacement.
I didn't say that.
You did.
Wait.
Like, no, I didn't.
Oh,
Never mind.
That's a question.
But it's gonna be 1.5.
Just, are you saying this is
What you doing? You did this.
State plan to include.
because I forgot.
Yeah, but we do this thing that we didn't take so.
Say that again. Oh, that's really
Like,
helpful.
we will
Colin.
be in a roll.
Oh, yeah. Hold on. Why did I do that? Should I just say see what? Look above?
Yeah. Say see above.
Do it. How do you do it?
It might just be
Yeah.
Well,
I don't know.
95%, you use the first one, but if it's 95%, you just now.
You can help me with it.
I don't know if it's right though.
But if you wanted to do it off your first norm, 0.975, yeah, you get it. 97.
It's not inverse.
Yes. No, that's where
It's inverse.
you're trying to find.
Oh, no, I'm looking for some stuff.
Oh, no.
I said the wrong thing.
It's something like that.
Where we good. Number you have to add like just size, so it's like point. So if it's 95, then you add 0.5 in.
No, it wouldn't be at all. 975 and then 0.
That's weird. Maybe get clear, and then try it. Because then I should phone. There you go.
Oh, there we go.
All right.
Oh.
Hannah's gonna state for us.
We have to draw.
You're gonna do.
Like,
No, this one doesn't have a picture.
I did.
But we just have to know the picture. We don't have to know the
Yeah,
details.
1 second.
You should identify.
Or is that right? That's right.
But it's
I
not
don't
like
know.
this.
Don't throw it in your
What?
But it's not essential to the
It is. Another one to the equation. You just don't have to draw pictures. Or you should have like a checklist of things you identify in your do. All right, thank you, Hannah. Then on the plan, the only thing that you needed to do, because we already checked the conditions, Hannah McFarland, what's our calculator function?
one prop.
Thank you, ma'am. 1 prop z int. Nate's gonna come do the do. Bless you. Thank you, sir. All right, so he put the general formula, confidence interval CI is equal to your estimate, which for this one is p hat plus or minus z star times our standard deviation. He even wrote down how to find the z star using inverse norm. You have to add one of the tails, so it's 0.975 for the area, mean 0, standard deviation of 1. So your z star is 1.96. Our p hat was 0.6 and our standard deviation was 0.041. And then when you put it in the calculator, you get 0.5216 up to 0.6784. Shelly is going to come conclude for us. Thank you, ma'am. All right, so conclude. You just have to say you're 95% confident that the interval captures the true proportion of high school students who have never smoked a cigarette. So our significance test told us that the alternative was most likely true, meaning P was not 0.5, but it didn't tell us whether it was less than 0.5 or greater than. Based on our interval, we see that it's probably greater than 0.5. Any questions? I would make sure you know how to do a two-sided followed by a confidence interval. I would make sure you know how to do a two-sided followed by a confidence interval.
For the test.
Zach read my mind. I might throw one on the test. All right, so how are confidence intervals and two-sided significance tests related? If the confidence interval does not capture the parameter value from H null, then we say the H null value is not plausible.
Not plausible.
And if the H null value is not plausible, that means we have strong evidence against the null hypothesis, and we're going to reject H null. So in other words, it tells us our p-value is less than alpha. If the confidence interval does capture the parameter value from H null, then we say that value is plausible. And we have weak evidence against the null. So we would fail to reject H null. In other words, our p-value would be greater than or equal to the alpha level. Nate?
Is there any scenario in which we do the test and get a p-value greater than alpha, but then we do a confidence interval and it doesn't capture H0?
I'm sure there's got to be a situation where you would do it. Am I going to make you do it like that? No.
Well, what would we conclude in that situation? Then we have a confidence interval that doesn't capture H0.
It's not going to be on the test. That's why.
I'll have to think about that one. I've never seen a situation like that. But, I mean, the thing about statistics is pretty much any situation can occur.
Yeah.
But I've never seen one like that. So I'll have to think about it.
So if our p-value is less than alpha, generally we're not going to find the H0 in our confidence interval.
Correct.
Okay. Same vice versa.
Yeah. Yeah. All right. Can I move it up? So my husband believes that the true proportion of the population that says that they hate math is 28%. To find out if this belief is true, he selected an SRS 500 people and 122 of them say they hate math. So, no state plan do conclude. Okay, I just want you to use your calculator, find a 95% confidence interval for the true proportion of people that hate math based on my husband's sample. And then, if it wasn't obvious, put it on that line that says confidence interval for me. I'm not a road person. I have done semicircles before, but this classroom is too narrow to do semicircles.
We should just do one of these. And like it could go around to the back too, and there's some space with it.
Let's do zigzags.
Yeah.
Let's turn this classroom into a lecture hall. Just add like
We used to have it like outline square cards of classes.
All right. Hopefully, you got the same interval as Tyler, 0.20635 to 0.28165. Now, if we were to do a significance test for this little situation up here, what is our null hypothesis? What does my husband believe?
28% hate math.
28% hate math. Is our 0.28 in our confidence interval? Yeah, it's just barely in there, right? Now, there's also a cool relationship between your confidence level and your alpha level. Since our confidence level is 95%, what do you think that means about alpha? What's the part we're missing? 95% confidence. So what percent are we missing?
But
5. And that's where alpha comes in. So if we're looking at a 90% confidence interval, alpha would be 0.1 or 10%. So, based on the confidence interval and what we talked about up here, whether your H null is captured or not captured, so ours was captured, the interval captured our H null, that tells us that our p-value is going to be greater than or equal to alpha. We know that our alpha level is 0.05 because we're looking at 95% confidence. So anybody want to make a prediction? And by the way, it is just a prediction. No wrong, no right here. Anybody want to make a prediction about what our p-value would be? Nobody? Say it again. Yeah, okay. Fair. P-value is greater than or equal to 0.05. How about something more specific?
0.057.
Thanks, Hayden. 0.057. Why did you stay close to 0.05?
Gotta predict it.
You didn't. You just threw it out there. You didn't have any thought process behind it.
I had a feeling behind it.
Okay. Well, I would have probably predicted something similar. I would have stayed really close to 0.05 because 0.28 is just barely inside my interval. If it was like in the middle, I'd go further away from my alpha level, but since it's just barely, I mean it's 0.00165 away from not being captured, so I'm not going to stray too far from my p-value.
That was my thinking.
You and I have always been like this. That's a friend's quote. By the way, who was in here with me when I was updating my friend's calendar? It's gone.
Someone stole it?
It's not here.
Your what?
It's on your
My friend's calendar.
Friend?
Maybe it just fell.
The TV show Friends. I can't find it. It makes me very sad.
Just retrace your steps.
It was like days ago that I did it.
Who would do that?
I kind of already said this, but just to actually put my explanation. All right, now you guys are going to do the do. Don't draw the picture. Don't write anything. Just type it in your calculator. Find the test statistic and the actual p-value for this situation. And let's see if our prediction was right. And I appreciate you throwing out a prediction because the rest of them just looked at me. What did you say? 0.06.
Horrible prediction. That's
Maddie
straight
said
too far.
0.06. All right, find your test statistic and your actual p-value for me, please. You okay?
122 divided by 5 like that.
You can do.
That's we do the restart.
Yeah, I'm so confused.
Yeah.
Oh, brain cells. I don't really specify, did I?
Huh?
What do you do? What's that one, how do you
Well, you need to come here and explain.
Oh,
There's like an application. It didn't take me that long, but I did a bunch of other PDO ones, so I basically copied and pasted it all. So I don't know, it probably wouldn't take me that long to do, I don't know though.
Why did you choose lesson?
Go to stats and then go down, yeah, 1% shows less than.
Oh yeah, because I calculated 1.2.
What? Is it a person? Well, usually you only do confidence intervals with two-sided.
Right here where it says it's greater. The one place where you select not equal, less than, or greater. No, that's a not equal, that's specified.
Wait, yeah.
Okay, so it doesn't specify you.
Which one are you supposed to
That's
choose?
what I know.
I'm just guessing.
Wait, did I do it?
Oh!
I'm
What
just
she said?
Thought you would detect it.
Yay!
I still the same answers.
Then you
How's
did
that
something
easy?
wrong.
We're talking about something.
That's what I got.
Wait, actually, how does that work? No, I think it doesn't.
All right. What's our z-score? Our test statistic?
-1.79.
-1.79.
I also got that.
And our p-value.
0.072.
So Mr. Maddie's prediction is too far off. Who was closer?
Yeah, well,
It was Hayden.
Maddie was closer.
they were like that. I chose a prime number.
57 is not
And
prime.
his was very
He means
specific.
prime is in good,
Yeah.
not prime is in action.
Prime not capitalized. Non-proper noun.
Oh my god.
Is prime like
Like it just, he means descriptive
For
too.
numbers in it's
Prime as an adjective.
Yeah, prime is in cool, good. Choice.
since when does prime
She chose a
mean
lame
cool?
number.
Prime rib.
What?
Prime rib. That's what prime means. Good.
You're in
It's
your
the good
prime.
part of rib.
You're in your prime.
I like numbers.
Dictionary.
He said he chose a prime number. What was my brain supposed to go to? Actual prime number. And it's not. It's divisible by 3. All right. Anyways, a couple of you did have questions about what you were supposed to choose on the alternative. We don't do confidence intervals if we are thinking the alternative is less than or greater than, because then we know which side we're leaning towards. We only work with confidence intervals when we're working with the not equal to, since it's two-sided, and the confidence interval is to help us figure out whether it's less than or greater than. Any questions before I say we're done? I mean, I want you to try the exit task, but we know how that's gone so far this year.
I think we should do it.
Sometimes I do.
Yeah, go ahead, do it.
But this time I
Man.
I'm done.
Yeah, just like
But